The purpose of this video clip is to demonstrate the creation of a simple application using Visionscape Frontrunner and the Visionscape Smart Camera. First step is to launch Visionscape Frontrunner. You observe the splash screen, and after a few minutes we will see the Frontrunner GUI. Select any available smart camera that you wish to program and hit the Take Control button and enter the password and username. Once this is done, you'll be offered the opportunity to upload any job that's on the camera. We'll decline that at this point because we want to start a new job from scratch. So select the Create New Program button, and that will cause the creation of a new empty job with just inspection and snapshot steps present. Okay, let's take a few pictures and make sure that the part we want to look at is lined up in the camera. Appears to be lined up nicely, and this is a simple electronic component, and the objective is to measure the distance between the left lead and the right lead and check that it is within tolerance. So the first step will be to press the left mouse button, do a drag in the screen, and this is one of the ways that you can bring up the Visionscape tool palette. Okay, we're going to insert a fast edge. Select it and see it arrive in the vision buffer. Move it to the desired position, and we're now going to adjust its parameters to locate the left edge of that left lead. Scan direction is correct, left to right. We'll make the adjustment to make it to look for a light to dark transition. Put away that tool datum editor page for a moment and click on the edge, and yes, it has found what we desire. So bring back the editor. We'll insert another tool into the snapshot, and again we need a fast edge tool. Put that one in and position it on the other lead we wish to locate. This is the lead on the right here. Put the tool in the right position and adjust again its transition, which we want to be from light to dark, and in this case we need to change the direction of scan from right to left. Check the tool by clicking on it. Yep, that is as desired. Okay, so we have located the two features we're interested in. Now we need to make a measurement of the distance between them. Again, select the snapshot step, hit insert, and now we'll go to a different category of tool. We'll be doing a measurement, and the measurement should be the point to line distance. We'll select that tool, and we'll see that it has two unassigned input datums. These are the point from which we want to make the measurement and the line to which we want to make the measurement. If I click on the input point datum, I will see some dots appear. Click on those, and I'll now see a step tree in which I can select the point from which I want to make the measurement. All the relevant datum types show up in blue. So the edge point for that first edge, the left edge, we'll select him, and the line we can select will be the edge point on the second edge. At this point I want to make a little adjustment to the way the tree looks. I think it's quite important to give each feature a unique name so you can identify it. So we'll call this edge the left edge, left fast edge, and this edge here the right fast edge. You can see that that will help identifying which step we're referencing in future. Okay, so let's run the job once here to see if it's working nicely. Yep, we have here the measurement from the point on the left lead to the closest approach of the line on the right lead. Things are looking good, so we have the measurement made. Now I want to insert a tolerance step to check whether that distance that we're measuring is within tolerance. So inserting right into the distance measurement, I hit insert. I see only the list of excuse me, only the list of steps that are relevant to insert at that point, and I want to insert a tolerance measurement. The tolerance measurement automatically picks up the distance coming out of the point-to-line measurement as its input datum. If I train it, it will take the current measurement and insert that as its nominal. A default tolerance here is 5%. Let's say I'm going to drop that down to 1%, and there we have a nominal of 194 pixels and a tolerance of just effectively plus or minus 2 pixels. I could adjust these numbers as required, so I'm going to change that to 4 pixels. And if I do that, I have to change to as is and change that to 4. Okay, 194 plus or minus 4 pixels is what we have, and I can run this job and it will pass because the part is within tolerance. I'll add one more feature to this little job, and that will be to signal whether the part is in or out of tolerance to a output step. That is a program control step. I'll select the digital output steps and look at its datum page. I see one expression, that's fine. The output I wish to connect will be a physical output, and we'll connect the first physical output, which is point number 2, output number 1. Now the expression I wanted to evaluate for setting that output, I can select that by clicking in the datum for the output expression, hit edit, and I will see my job again as a list of steps, and when I select a step I will see the steps datums. In this case I wish it to set the I/O point according to the status of the tolerance measurement, so I select the tolerance measurement, select its status and add it to the expression. The value of that datum will be evaluated. If it evaluates to true, the output point will be set to on, and that's what I want to happen, so the output is on if the part passes. So we'll say OK there, and we're all set to run this job. Clear up a little bit, save the job. You might want to use it again, give it a name, and save it as an AVP. OK, we can run the job. We'll see that it is passing. If I occlude the part so that it cannot see that edge, it will fail. OK, so we'll stop the job, and we're ready to go into run mode now. To run it, I have to first download it to the camera. The job is now downloaded, and we can set it to run in the run screen of FrontRunner. What might be interesting will be to observe the I/O, so I'm going to stop the job for a moment. I'm going to bring up an I/O display, put the job back into run mode, display that I/O display, and I'll see that I/O is on when the part passes, and if it finds the wrong lead, the I/O goes off. So now I have here a simple job. It takes pictures, it locates features, it makes a measurement, and it reports the status of that measurement to the outside world in the form of a digital I/O point. This contains all the essences of a useful machine vision job. It measures and it reports. So all that's left here is to shut this job down. We'll close down the I/O display. We will turn off the smart camera, stop it running. I could have left it running if I wanted to, and shut down FrontRunner. That concludes this little demonstration of the basics of Visionscape.